Hello everyone, this is Mr. Underkoffler. Today we're looking at the guided notes called Surface Area of Composite Solids. Alright, follow along with me here as I read this out loud. To find the surface area of a composite solid, you cannot simply break the 3D figure into separate 3D figures, find each of their surface areas, and add them together. Why? Because not every side is exposed in the original composite figure. For example, take a look at this composite figure. It looks like we have a rectangular prism at the bottom and a triangular prism that is smacked on top of it. But here's the deal. You can't just find the surface area of the triangular prism and then separately find the surface area of the rectangular prism and add them together. Here's why. The bottom of the triangular prism and the top of the rectangular prism are not exposed in the original composite figure. Therefore, their areas do not get added in with the areas of the other sides. Well, then what do? Here's what you do. You're going to have to find the area of each side. Not surface area formulas, but actually area formulas for each side. Not the sides that are not exposed, just the ones that are exposed, and add them together. Now, to save time, we're going to figure out which sides are duplicates of other sides. Okay, so for the shape we've been looking at, triangular prism at the top, rectangular prism at the bottom, as you can see, we are going to look at each side separately and find its area. Are you ready? Pencils in your hand. So this rectangle that was slanted at the top, what are its dimensions? Well, clearly the length was 9.5 feet. Go ahead and label this with me. But what is the width going across? The width going across is the same as the width going across down here at the bottom, which would be 6 feet. So this first rectangle that was slanted is 6 feet wide and 9.5 feet long. All right, what about this rectangle here in the front? Well, it's still going to also be 6 feet wide, but how tall is it? Well, let me zoom back out to the full shape. The height here of the rectangle here would be the same here, which would be the same back here, this 8-foot section. Not the total 11-foot section, but just the 8-foot section. So that's going to be the length here of my rectangle. So let's go ahead and write that down. As we just said, 8 feet tall. We will eventually do length times width and length times width, but let's keep putting the lengths and widths of each of these rectangles. What about the rectangle at the bottom that you can't actually see? Again, let me zoom out a little bit. The rectangle at the bottom that I cannot actually see would be 6 feet wide and 9 feet long. So let's go ahead and write that down. 6 feet wide and 9 feet long for the rectangle at the bottom that we could not really actually see on the original drawing. All right, moving on. How about the right side here? We got a triangle on top, and we have the rectangle here on the right side, and we also have the one in the back. Let's go ahead and start with this rectangle here on the right side. And I want you to realize something. This rectangle here, it actually duplicates. If I can zoom out to the original shape, this rectangle, I should maybe really make this green so you can see it. This rectangle here would duplicate on the back left side, which we can't really see from this perspective. So there's actually two of these guys. So let's go ahead and write that down. There are two of these rectangles, and their measurements are pretty clear to see. 8 feet tall, 9 feet wide. Go ahead and write that down on this rectangle. And again, there's two of them. There's one on the front right that we were able to see, and there's one on the back left that we were not able to see. Okay, speaking of rectangles we can't really see, there's a big rectangle in the back. And it's not just 3 feet tall. It's not just 8 feet tall. It would be 3 plus 8, which is 11 feet tall. Now, how wide would the rectangle be in the back? Well, the width here would actually be the same as the width going across here. So that is 6 feet wide, and that's how wide the rectangle would be in the back. So let's go ahead and write that down. And then finally, back here to the side, we have a triangle. This triangle is 3 feet tall. It is 9 feet long because the length going from here to here would match down here. So that's 9 feet long. And not only is there one here on the front right side, there would also be one on the back left side that we cannot see. So this is the other shape that had a duplicate on the other side. And by the way, if you're like, wait a minute, Mr. Underkoffler, couldn't the triangle and the rectangle be combined to make a trapezoid? Yes. Now, you could have done that, but I'm not going to because I think most students would have seen this top little piece as a triangle. But you're right. I could have made this, instead of this shape here with a triangle and this rectangle down here, notice how they're both duplicates, I could have just made them one big trapezoid that are duplicates. So yes, you could have done that. Okay, let's start back at the beginning with the slanted rectangle, and let's do area equals length times width. Now, I am not going to make you copy down this formula every single time. If it's just length times width, you can just go ahead and multiply those numbers together. Not a big deal. So go ahead and use your calculator. 9.5 times 6, boom, should give you 57 square feet. You don't have to put the units of measure yet. You can just call it square feet. All right, 8 by 6. 8 times 6 is 48. I hope you're writing all these things down with me, ladies and gentlemen, because we are now finding the areas of each of these individual shapes. So we got 57 up here, 48 down here. What about this rectangle from the bottom that we couldn't see? 9 times 6, or 6 times 9, either way, gives you 54 square feet. I hope you are writing that down. Hit pause if you need to catch up. Hit rewind if you missed something. Do what you got to do as you watch the video. All right, let's continue. The rectangle down here, that had 2 of them. So 8 times 9, but times 2, because there's 2 of them, is going to give you, well, 9 times 8 would be 72. Times 2 is 144. Please write that down. The rectangle here that came from the back side that I could not see, that was 3 plus 8, which was 11 feet tall. 11 times 6 is 66. Why do I have all these things covering it? My apologies. There you go. Finally, the triangle. The triangle would be 1/2 times base times height to get the area. But there's 2 of them. So that's 2 times 1/2 times the base times the height. And I hope you guys realize that if I take 2 times 1/2, 2 times a half is 1 whole. And 1 times BH is just BH. So if you're doing 2 triangles, it's really just base times height, because the 2 times the 1/2 basically cancel themselves out. You're left with the base and the height. Base was 9, height was 3. We got 9 times 3, boom, 27. Are you writing all of this down? Okay, here's a recap. We had 57 on the left, then 48. If I keep going around, we had 54. We had 144 from the 2 rectangles that were on the side and the other side. We had the big rectangle in the back we couldn't see, which was 66, and the 2 little triangles giving us 27. If you would have done 2 trapezoids, then you would have had the 27 and the 147 already together as 171, if you would have done it that way. All right, the final thing we have to do is add all of these areas together. So are you ready? I believe there's a horizontal line separating this problem from the one underneath. Right above that horizontal line, you can start writing this down with me. We got 57 plus 48 plus 54 plus 144 plus 66, and finally plus the 27 from the 2 triangles. Add those in your calculator. Please feel free to do that right now. Hit pause if you need to. and that should give you 396 square feet. And since this is now the final answer, I will label it square feet. Not cubic feet, it's not volume, it was surface area. Problem number 1. Why don't we have you try this one on your own before you do the ones on the next page? Let's just have you do one here to make sure you're able to get it right. I will say, spoiler alert, this one's a little bit nicer than the last problem we were just doing together. So hit pause, try this one on your own, and then hit play when you're ready to see how you did. Okay, did you try number 1 on your own? You can see we have a big triangle and we have the square sides of the cubes. Now, how many triangles do we have? We have the one here, the one here, the one in the back there on the left, the one in the back right. That's a total of 4 of those triangles. How many squares do we have? Well, you can't count the square on the top because it is not exposed. So there's only 1, 2, 3, 4 going around the sides, and then the one on the bottom does count as well. So that is a total of 5 of those squares. Okay, the dimensions of the triangle, we need the height, which is pretty simple to see, that's 16 5/8 inches. And then the base of the triangle would be the same as this 8.5 inches going for the side of the square. So they're going to be the same. So hopefully you went ahead and wrote that down. And then for the cube, for the squares, we have 8.5 by 8.5. So it's 8.5 for every single side. All right. Now let's do the work. Area of a triangle is 1/2 times base times height, but there is 4 of them. So 4 times 1/2. What would that give you? 4 times 1/2 is 2. The base is 8.5. The height is 16 5/8. Multiply this together. Now, by the way, if you wanted to keep it 4 times 1/2 and then times 8.5 times 16 5/8, that's fine. You can do that. No big deal. I'm sure your calculator can handle it. You should have got an area from the 4 triangles of 282 5/8, and this was square inches. Yes, square inches. Not that you have to write the square inches quite yet. This is not our final answer. For the 5 squares, area of a square is s to the second power, but there's 5 of them, so you could do 5s to the second power, or s to the second power times 5. I don't really care which way you write it, doesn't matter. Put the 5 first on the left if you want. Put the 5 on the right, doesn't matter to me. So that's going to be 8.5 to the second power times 5, and that should have given you an area of 361 1/4. Add them together, and this is going to give you a total area of 643 7/8 square inches, because surface area is square units, so square inches. All right, that wasn't really that bad. Why don't you go ahead and try the remaining 3 problems on your own? So we got number 2, we got number 3, and we got number 4. If you have your guided note set, you should already have these problems to look at. So hit pause now, do 2, 3, and 4 on your own, and then hit play when you're ready to see how you did. Okay, did you already do number 2, 3, and 4 on your own? Problem number 2. What were the shapes that we had? Well, we had a trapezoid, and there was 2 of them, the one in the front and the one in the back. Now, you could make this a square, and that square would have shown up twice, and then you would have had a triangle here and a triangle here. They're actually identical triangles, and there's 2 others in the back, so there'd be a total of 4 triangles. But I'm telling you, the easier way of doing this was thinking of a trapezoid in the front and a trapezoid in the back. Definitely the easier way. We have a base height of 4 up there and a base height of 10 at the bottom. And am I saying height? Why am I saying height? Base length of 4 and a base length of 10. The height in between is 4. All right, we have a rectangle going here and here. There's 2 of those rectangles. They are 5 feet long and 3 feet wide. And then we have the rectangle on the top, which does not duplicate anywhere else because The bottom is left completely open. That's a key feature to problem number 2 for this fabric cover, is that the bottom is left open. So we have a rectangle on the top, and it's only one of them. It is 3 feet wide. Now, how did I know it was 3 feet wide? Because the width here is the same as the width here, so that's 3 feet wide, and definitely 4 feet long. That should be pretty obvious. All right, so for the work, area of a trapezoid is 1/2 times height times b1 plus b2 in parentheses, but there's 2 of them, and the 2 and the half cancel each other out, leaving you with just the height and the bases. 4 plus 10 is 14, times 4 is 56. For the little rectangle, 4 times 3 gives you 12. For the big rectangle, but there's 2 of them, 5 times 3 times 2 gives you 30. Add all of these together, and you should get 98 square feet. All right, problem number 3. This is a really fascinating looking 3-dimensional composite solid. What do we have here? Well, we have 2 very big rectangles, the one here and the one that's like it down here. So 2 of those, you can see it's 14 long and 10 wide. We have 1, 2, and then there's duplicating in the back, 3 and 4. These triangles are the same. How do I know? They both have heights of 8, and they both would have base lengths of 14, because the base length there is the base length back here. You see it's confirmed to be 14 here as well. This is how I know these triangles are the same. So there's 4 triangles that are exactly the same, having heights of 8. Sorry, did I say heights of 8? My bad. I said the wrong thing. They are heights of 3.9. I apologize. I was saying the wrong thing. They are heights of 3.9. The 8s are actually the length going this way, so that's not on the triangle. So, and I already said the base was 14. For the rectangle in the back here and the back here, they have a width of 8 and a length of 10. And there you go. And there's 2 of them. There's the one that's kind of in the back top and the one in the back bottom. So 10 by 8. We have 2 of them. All right. Let's do the areas here. For the rectangles that were 10 by 14, total surface area, total area of 280. For the rectangles that were 10 by 8, total area of 160, because there's 2 of them. For the triangles, 4 times 1/2. 4 times a half is 2. Not that you necessarily have to simplify that if you don't want to. I'm sure you can do it in your calculator. 4 times 1/2 times 14 times 3.9, giving you a total area of 109.2 for those 4 triangles. Add all of these together, and you're going to get a total surface area of 549.2 square centimeters. And finally, problem number 4. This kind of looks like a barn, or a really not tall house with a huge roof. I'm not quite sure what you would call this thing. So let's break this down. What do we have? Well, we have the 2 triangles. They're pretty obvious. The one in the front, the one in the back. 2 of them. Height of 3.5 and a base length of 4, because the length going down here of 4 would match as the base length here of the triangle. We have some really skinny rectangles. We have the one here in the front, which would match the one in the back. So there's 2 of them. They are 4 feet long and only 1 foot tall. Then we have the skinny rectangle on the right side and the back left side. They are 10 feet long, still only 1 foot tall. There's 2 of those. And then we got the big rectangles, the one here on the right and the one that's kind of in the left. 2 of those. They are 10 feet long. You can see here the length going here would match the length going here. And the width is 4 feet here on the slant. So there you go, 10 by 4. Oh, I overlooked this. There's 3 of them. You're like, wait a minute. There's only 2 slanted rectangles. I know. But did you notice the rectangle at the bottom is also 10 feet long and 4 feet wide, which is the lengths of the slanted rectangles. So that's why I said times 3. The one at the bottom, coincidentally, was the same measurements as the slanted rectangles at the top. They might not have looked that way, but that's because perspective, when you look at a three-dimensional figure, is not always accurate for how you would look at them straight on. Okay, so let's do the work. For the two triangles, 2 times 1/2 cancels out the 1/2. You're left with the base times the height, which gives you a total area of the two triangles of 14. For the 3 big rectangles, 10 times 4 times 3 gives you 120. For the little tiny rectangles, 4 times 1 is 4, times 2 is 8. For the 2 skinny 10 by 1 rectangles, that's going to give you an area of 20. Add all of these areas together in any order you want. You're going to get a total surface area of 162 square feet. And that concludes the guided notes on surface area of composite solids. Thank you for watching. We'll see you next time.